Algorithm. What is an algorithm? An algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. So if we want to do a task, the steps we do in doing that task is what we call the algorithm. So to give you a real-life example, I have here a picture frame with several family members. And let's say what will be our algorithm in counting the number of members of the family inside the picture frame. To do that in real life, maybe we just have to point at each member of the family and start counting one by one. So let's say we point at the first person, then that's 1, then 2, 3, 4, 5, 6. So that means there are actually 6 members of the family inside the picture frame. We can write a pseudocode for that algorithm. So here is an example of a pseudocode. A pseudocode is actually a code that resembles that of a programming language, but it is not a real programming language. So it does not really follow formally the syntax of any programming language. So in this example, we have here the first line, which says let n equals 0. So that is actually where we initialize a variable, or a variable is actually a memory location or something that will be used in counting the number of persons. So n equals 0 because at first we haven't counted anything yet, so that means it is still 0. And then the next line is for each person in the picture that is actually the start of a loop. So that means for each person, be adding 1 to the value of n. And that will be looping several times until we are through with each picture inside the picture frame. Now let's try to simulate. So initially the first line is let n equals 0. That means n is 0, or we haven't started counting yet. And then we'll start with the loop, so for each person. And then there we are now on the first person. So n equals n plus 1. That means we're going to add 1 to the value of n. From 0, n now is equal to 1. And on the next loop, again, add 1 to n. So n now is 2. Then on the next iteration, it's now 3. And then 4. And then 5. And then 6. Okay? So we have here now our algorithm. But maybe we can make it even faster. How? Maybe we can make it faster by counting by twos, by pairs. If we're going to count by pair, let us now do some changes in our pseudocode. So I'm going to replace the start of the loop into for each pair of person in the picture. And then instead of adding 1, I'm going to count by 2. So I'm going to add 2 to my variable n. So I'm going to do that. So on the first loop, n is 2. On the second loop, n now is 4. And on the third loop, n now is equal to 6. So that's quite faster than the first algorithm. But will that work for every picture frame wherein we want to count the number of persons? So let's take a look at another picture. This time around, let's see, do you think that will work? Maybe no. If we're going to count manually without using the algorithm, there are actually 7 members. And that means that grandma here will be left behind. She will not be counted. So that means we're going to make some changes with our algorithm. So I'm going to add here another code that if there is 1 person left, then we add 1. So bottom line here is that can create algorithms in doing several tasks. And the task or the step-by-step procedure that we do is actually called the algorithm. Thank you.